Chemistry, this is the answers video for day 48. Now you see that there is an absolute deadline coming up on Tuesday for this. This must be turned in by Tuesday or it won't be accepted. So I'm putting this up to be sure you get most of this assignment done at least. Also for those of you who have done it and want to check and be sure you've done these problems correctly. So the first page deals with solubility rules. And the first two columns are done on the lecture video. So watch the lecture video. The only ones I'm asking you to do are these, and be sure you do those correctly. You know how to do solubility rules. Then we go on and problem A, there's 4 problems, A, B, C, and D. Problem A is already on the lecture video as well, except how to do this step by step. So you should do this. I'm going to do B and C. I'm going to leave D undone for you to do on your own. Okay, that is going to be the majority of the grade on this is problem D, the one that I'm not going to do. So let's go ahead and get through B and C. So it says silver nitrate and sodium chloride. You're going to create a reaction between those two. So let's see how to do that. First, you have to know how to write the chemical formula from those. So we have silver is Ag. So we're going to put Ag. And nitrate. Now that one you need the 60 common ions because that's not an element. So I'm coming over here. You go down to the third group down here and there's nitrate. It's NO3 and you see it's a 1 minus. You want to make a note of that. And now you're going to create sodium, or you're adding that rather, sodium, Na, and chloride, Cl, table salt. Okay? So there are the reactants for this reaction. The next thing is to create a double replacement reaction. You just simply switch the silver and the sodium. So we're going to come over here. We're going to put the sodium along with the nitrate. And it doesn't matter which one goes before the plus sign and which one goes after. And we're going to put the silver with the chloride. Okay, there you go. So that's the double replacement reaction. So I actually did that step there. It's okay to combine those two steps. So this was just write these two, and then this was to write the whole thing down here. Okay, determine the charge number. And for silver, so now I'm going to ask you to rewrite it a second time if you didn't already, or even a third time. Okay, silver, it says, is 1. It's a 1 charge to it. Okay, so it's 1 plus. And nitrate is, we saw on the previous sheet just a minute ago that it's a 1 minus. Sodium, Na, is a 1 plus, and chloride is a 1 minus. So now we come over to this side. Sodium, again, is 1 plus. NO3 is 1 minus. The charges don't change. Ag is 1 plus, and Cl is again 1 minus. Okay, so you see that everything is in balance. As long as these two numbers are the same, the only thing different is the sign, then they're in balance. So you don't need to do this. You don't need to add subscripts. They're all 1s. And you don't need to write subscripts of 1. So I'm going to just write not needed. Okay, now we're going to use solubility rules. So AgNO3. So we go to the solubility rules. And what it says is, just look for either of those compounds. Here, NO3 is soluble with anything. There's no exceptions. So this is going to be, so we're going to write it out again. It's aqueous. It means it's going to dissolve in water. NaCl, sodium, dissolves with anything. Also aqueous. Now we have NaNO3, and we already saw that NO3 dissolves with anything. And then AgCl, we come over here And we see that Cl dissolves with anything. It's in the soluble column except if it's attached to one of these three. And it is, AgCl. So that's not soluble. That means it's going to form a solid called a precipitate. And that's a solid. Okay, so that's how you do solubility. Now we are going to balance the equation. So I'm going to write out the equation without all the charges and aqueous or solid, just so we can see how to balance it. Okay, and we're going to write each of the elements. Now this NO3 nitrate, we can treat as an individual element because you see it's not going to come apart. It's not going to change from reactants to products. And in fact, I'll say that is true for anything that you see down here, nitrate, iodate, nitrite, anything down here, these are not going to come apart in solution. They're not going to dissolve. You're not going to have, for sulfate, for example, the S's and the oxygens coming apart. So you just treat them as individual elements. One way to emphasize that is to put them in parentheses. So here we go. I'm going to go ahead and write these down here. And I'm going to treat NO3 like an individual element. Okay, so silver, NO3, Na, Cl. They're ones on both sides, so they're already in balance. You don't need to put anything, you don't need to put any coefficients in front, although you might want to put a 1 in front of these to emphasize that there's one of each of those. Okay, now we come down. Separate all the ions. Okay, this is going to be the complete ionic equation, and this is it's long, so you start way over on the left and you write this. Okay, this is it, the complete ionic equation. All of the AQs are broken up. You should show the charge on them and that it's aqueous on each one of them. Like this, they're all broken. The one that is not going to break apart or dissolve is the AgCl. That you show as a solid, that's the precipitate, and you don't have to show the charges above the AgCl. It's electrically neutral entirely as it's put together. So now we're going to eliminate all ions as they appear on both sides. I'm going to do that up here on the same equation. You can do that also. So what we have is NO3 here and NO3 here appear the same on both sides. Na here and here appear the same on both sides. Put a box around everything that you didn't cancel out. Okay, so what I'm writing is for this step down here with all the cancellations in the boxes. And now you have your net ionic equation. And that is your final answer. That's the final net ionic equation. Okay, I wouldn't combine too many more steps that I'm showing right here when you do this. Some people who turned this in took some real shortcuts on this. I want to be sure you know how to do this properly. Okay, there we go. We're going to go on to the next problem. Okay, here we go. We're on C. And it's lead 2 nitrate. Now, on the original copy of this, I did not put the 2 on. It has to be lead 2. You're going to see why in just a second. So again, lead is go to either your periodic table or your 60 common ions. And lead is Pb. And now you notice I didn't include the 1, 2, 3, 4, all the steps. I want you to do this on your own. And nitrate, you come over here. The only place you get that is because it's not an element, it's a compound. You have to get that off of this, and it is down here in the third group, and there it is, nitrate, NO3, and it's a 1-. You just want to keep that in mind in just a second. Plus lithium. And you can go to either sheet for this one. There's lithium, it's Li, it's a +1. We're going to remember that. And bromide. And that's Br, and that's a 1-. It's right there. You could have gotten that off either sheet. Okay, now I'm going to combine steps 1 and 2 here, and I'm going to go ahead and do the double replacement reaction right here, okay? Go ahead and do that. So that means that they're going to switch places, so the lithium comes over to be with the nitrate. Again, let me go ahead and put the nitrate in parentheses because we're going to treat that like an element that's definitely not going to come apart. It's not going to dissolve. And then we have PB and BR over here. Okay, so these two just switched places. All right, so now we've done steps 1 and 2. Step 3 is determine the charges on each one. Okay, so we can go ahead and do that in the same, but I'm probably on a test going to ask you to write it another time. So it's PB, and it says it's lead 2, so it's 2 plus. And the NO3 is 1 minus. Okay, next is lithium. Okay, we just saw that lithium was a 1 plus, and we just also saw that bromide is a 1 minus. Now those charges are not going to change on the product side over here, so we switch places here. Well, excuse me, we already did that, sorry. So lithium is 1 plus. Okay, there's the charges. Now you have to use crossing arrows. This 2 comes down over here, and the 1 comes down over here. You drop the negative sign, or the plus sign both. So it's going to be PB, 1, NO3. Now the way you have to write this, because there's 2 now, the 2 comes over here, that's where you have to have the parentheses. It's not optional. You have to put a parenthesis, it's NO3, and then there's 2 of those. Okay, they have to. So you need 2 of the NO3s to match up with the 1 PB. Okay. LIBR, 1 and 1, so they balance already. LiNO3, they balance already. And PBBR, you need 2 BRs for every 1 PB because you need 2 negative ones to balance with the 2 plus. So it's PBBR2. Okay, so now we've taken care of charges. Now we need to adjust the subscripts, which we did. We did that already, actually. That was step 4. You do need to do that, so that has to be a 2 there, and there has to be a 2 there. Okay, now the solubility. So we're going to do that in the same step here, okay? So the PbNO3. So again, go to your solubility rules. And NO3 is soluble with anything. There's no exceptions to these up here. So it's AQ. LIBR, lithium, soluble with anything up here on that top left. Li, again, LiNO3, those are both soluble with anything, so that's aqueous. And PbBr, so here we come here. We see that bromine is soluble with anything except for these 3, and one of those is lead, and specifically lead 2. Those are insoluble, so that becomes solid. Okay, now we are going to balance the equation. All right, so we're going to start with, doesn't matter which one, we can start with the BR. We have 2 on this side, 1 on this side, so we're going to need to put a 2 there. Okay, so that makes this a 2. It also makes the lithium a 2 right there. So now we need to balance the lithium. Lithium 2, lithium 1, we're going to put a 2 there. So this is going to become a 2. It also makes the NO3 a 2. Okay, so 2 Li and 2 NO3 there. And so everything now is in balance, all right? So I'm going to just rewrite it. You don't have to, but it's 1, 2, 2, 1, okay, in front there. Okay, I'm just going to rewrite that so it's cleaner. Again, I do like to write coefficients of 1. Okay, there we go. There's everything with the coefficients. Put the 1 in front of that, and we're good with that. Okay, next. Now we have to break them into separate ions. Anything that says AQ has to be broken up. So here we go with that. And to do it properly, you have to write both the charge. You get on screen here, you have to write both the charge and that it's aqueous. Okay, there we go. That's the complete ionic equation. And now we cancel anything we see on both sides. Here's the arrow right here just to emphasize. So Pb, no, NO3, this should have been NO3 too. I messed that one up because it's NO3 2, NO3 2, NO3. I should have put it in parentheses, 2. Okay, and that means then once you break it out into ions, it becomes 2NO3. So this 2 goes away. Again, it's not breaking into an NO3 2 molecule. They come apart. So again, if you were to draw a picture of just this compound, I'll just do this one. It's Pb. And then you have an NO3 minus, and then you have another NO3 minus. Okay, NO3 minus, NO3 minus. All right, so you have 2 NO3 minuses. That's what it's saying. Okay, so this cancels with this, and the Li cancels here and here, and the only things you have left are the lead, the bromide, and the 2 of them put together. Okay, so these are called spectator ions. The ones that canceled out because they don't appear. They appear the same in the reactants as they do in the products. That means they didn't take part in the reaction. Nothing changed about them. So this is the net ionic equation. So it's Pb. Okay, and there's your net ionic equation, and that takes care of this answers video. So D, you do on your own. And it should be pretty straightforward from the 3 examples that you have.